Hello, and welcome to video number 5 in the series, Educational Videos for Novice Java Programmers. Today, we'll be looking at some more basic semantic errors. Today's video includes loss of precision while casting, the control flow reaching the end of a non-void method without returning, and trying to invoke a static method as if it was non-static. Let's get into the video. So let's start with loss of precision while casting. Just a reminder that the version of the tester class used in this video is available in the description below, so don't forget to pick that up. So let's begin. If we double click on the tester class over here, inside the run method, I've laid out a few things that would be really beneficial to illustrate the first part of this video. So as you can see, I've just laid out a simple problem of student 1's marks in Java and databases and adding them up to a total. Simple, right? Notice, however, that Java and databases, the marks, are of type double and have the values 80.5 and 92. Can also be written as 92.0. But let's leave it as 92 for now. And if we notice here, I'm casting it to an int because that is the type of my total variable. Now what happens here is because double has a decimal point and integer does not support a decimal point, when I cast it to an integer, I lose precision. That is, I lose the 0.5. Now, you might be wondering, why not just leave the int out there and see what happens? I'll show you what happens. If I forget the casting, I immediately get a compiler error that says incompatible types. Total is expected to be an integer, but we're trying to assign a double to it. So this is why it's important to use the correct data types whenever we're doing especially arithmetic, because there is a chance that you might lose precision and the end result of the program may not be what you expect it to be. So let me show you how casting actually affects the result. So if we go back here, comment this out, and use the int total, and we need the casted statement over there. Let's try to run this. Now what we should see here, as we do, is a loss of the decimal point. That is, a loss of precision. So this answer is not as accurate as it could be. Now it may not make too much of a difference here, but in more critical systems, that loss of precision could mean a lot more than somebody getting a lower mark. Now let's try that again with total as a double variable. If we change those, uncomment that and comment this statement out, and run this again, we should now see correctly the 0.5 on the end. That is the difference that a loss of precision makes. Now, casting can occur across various different data types, whether they be class types or primitive types. But generally, the loss of precision is most notable while using arithmetic types, such as byte, short, int, long, double, float, etc. So always remember to use the correct data types while casting. The next thing we're going to be looking at is reaching the end of a non-void method without returning. Let's go into the tester class again to see how this works. If we scroll down to the doClassification method, we can see that this method is taking in a total, calculating the average, and classifying them into a first, upper second, lower second, third, or fail. Now, One thing you can notice here is that I'm using if and not else if, and you might be wondering, is that not inefficient? In this case, no, because as soon as a return statement is reached, it exits the method, and therefore none of the statements are ever reached. So the consequent if statements can only be reached if the ones above it are not true. This is a good point to keep in mind. Now, a lot of the time, while using if statements, people forget to give weight to the final case. So, if people say, if average less than 40, return fail, I get this error here, missing return statement. That's because I don't know, the method doesn't know, in fact, what to return if none of these if statements are true. Therefore, it's always good to remember that you need a return statement that is independent of these if conditions. The last thing we're going to be looking at is invoking static methods as if they were non-static. This is another common error amongst Novice Java programmers. To start with, let's talk about what a static method is. A static method is one that belongs to the class and not the objects of the class. Therefore, if I create several objects of a class, for example tester, this static method will be shared across those objects, or instances as they're sometimes called. Let's go into the tester class so I can explain this in a little more detail. So static methods can be easily identified by the use of the keyword static in the function signature. This makes the function static, and it also means that everything inside the method is in a static context. Now, few properties of static methods are that they cannot call any non-static methods or variables. Therefore, you have to create an instance of the object that you're trying to call. And because that object is now in a static context, you can call methods on that instance. For example, here, in order to call the method run, I need to create an instance of the object tester and then say tester.run. If we try to call run on its own, we get an error here saying non-static method run cannot be referenced from a static context. This is quite a tricky pitfall that most Novice Java programmers make, and might be sometimes harder to wrap your head around. I hope this helped.